let me present the main recommendations for control rooms. I'm going to talk about the EBU, the 3276 from 1998 and 2004, and also the P&E wings, from Recording Academy's producer and engineers wing, and a brief summary of the recommendations from Dolby Laboratories on the top. This recommendation, it was published for stereo format in 1998, and in 2004 a supplement was published for multi-channel sound. Right at the beginning, we have the definition of some acoustic terms in order that the recommendation can be well understood. The reverberation field must be, as recommended, sufficiently diffuse over the mixing engineer area to avoid undesirable acoustic effects. Anyone, like we said 1,000 times, like flutter echo or computer, whatever, can change our frequency response. Early reflections are the reflection from surfaces in the control room, which reach the mix engineer within the first 15 milliseconds after the arrival of the direct sound. Those reflections must be at least 10 decibels below the level of the direct sound for low frequencies between 1 kilohertz and 8 kilohertz. The reverberation must be measured with 1/3 octave band, 1/3 octave filtering, using the audio monitors as a sound source. We use the parameter called TM, which is the ideal average of measured reverberation time in 1/3 octave band from 200 hertz to 4 kilohertz. So I'll show an equation here, and we have the TM. That's a simple formula. The value of TM should increase with the size of the room to ensure a natural sensation of reverberance in the control room. Just like we can see here, TM and 0.25 multiply V, which is the volume of the room in cubic meter. And we have right here, the V0 is the reference volume of the room. It's 100 cubic meter. So it's a kind of simple equation, and you can have the ideal average of reverberation time in 1/3 octave band for your room. The reverberation time is measured in 1/3 octave band over the frequency range from 62 hertz to 8 kilohertz, and should not exceed the limit present in this picture here. We have this line, it's TM, and we have a variation here, a tolerance, it's 0.1 second, right? The total tolerance. The operational room response curve describes the frequency response of the sound pressure level produced by the audio monitors at any listening point. In our case, will be measured from the mix engineer spot. The pink noise is used as a test signal for this measurement at 78 decibels. This criterion is very important in the evaluation of the control room and the audio monitors. The tolerance limit we can see right here is plus or minus 3 dB, and here we have the line that corresponds to 78 decibels, and the measuring is between 50 hertz and 16 kilohertz. So right here, 2000 hertz start to increase our tolerance 1 dB per octave. Each monitor's measurement should meet the recommendation tolerance. Each channel must be measured individually and perform within that margin of tolerance. In some rooms, especially small rooms, it can be hard to get a good result at low frequency. Sometimes we can see rooms like 5 or 10 dB more than the tolerance. That's really a big trouble. An alternative to improve The result of the measurements is to change the placement of the monitors and the listener without changing the angle between the monitors and the listener. It is also common to find equalizers being used as a resource for this linearity because the acoustic treatment and the placement of the monitors and the listener are not sufficient. This electronic adjustment should be made only on the frequency below 300 Hz. In the case of 5.1 monitoring, the five monitor speakers must be identical, I mean same manufacturer and model, as some monitors do not respond well to low frequencies. It is, in case of stereo monitors, it is common to have the lows redirected to a subwoofer. The rear monitors can also be equalized only up to 300 Hz. It can be difficult to achieve the results for the operation of room response curve at low frequency within the tolerance range, especially in small rooms. In this case, we should first read it acoustically and also may change the monitor's position and the mixing spot. But always, keep in mind this, but always maintaining the equilateral triangle between the two speakers and engineer. If you still cannot get satisfactory result after these steps, the equalizer can help. The background noise from air conditioning systems, equipment, and from outside should be measured at the mixing position in the control room. It must be sampled at a height of 1.2 meters or around 4 feet above the floor. The NR value should be above NR10 and should never exceed NR15. So also show here another picture. We can see from EBU, we have the values for NR curves, all right? Here is the frequency, and here is the value, and here we have the chart. The height of the monitors, the acoustic center should be at least 1.2 meters above the floor and should be pointed directly to the engineer's ears, which is also, should be also around 1.2 meter from the floor. In cases where the monitor needs to be angled, when the acoustic center is higher than 1.2 meter, this angle should not exceed the 10 degree. If you have too much, your monitor is too much angle, you're gonna have a very small sweet spot. The minimum distance recommended between the walls and the monitors is 1 meter or about 40 inches. And between the listener and the walls, the side walls or back or front walls, is 1.5 meter or about 5 feet. No object or anything that could obstruct the direct sound should be allocated between the engineer and the monitor speakers. Another picture here illustrates the setup recommended for 5.1 monitor in the control room. Right in the middle, we can see the reference listen position, which is called here like number 3, okay? Up here, we have the left monitor, and here the right monitor. We can see that the angles between the left and right loudspeakers and the listener should be equal to 60 degrees, just like I said, an equilateral triangle. No matter how far the monitors are positioned, that equilateral triangle must stay the same. The distance between the loudspeaker and the listener is always the same from left, right, center, left surround, and right surround. The distance should fit the tolerance range between 2 and 4 meters. This distance is recommended for monitoring 5.1 as well as 2 channels. The proportions of the room lie within the tolerance present in the following picture. So here we have L, which is length, W, width, and the height. All right, and we have equation 1, equation 2, and equation 3. All right, that's about the proportions. The proportions of the room should fit this tolerance present in these 3 equations here. The room must be reasonably symmetrical between left and right sides. Not only the walls and the geometry, but also the acoustic treatment like absorption, diffusion, or reflections. Any objective or structure that resonates due to the audio coming from the loudspeaker must be sufficiently absorbed or else removed from the environment. Absorbers, diffusers, and objects should be positioned so as to avoid further echo and specular reflections. That also, your mixing desk can cause early reflections, so it's very important to pay attention also in your mixing desk. I also want to mention some important recommendations from Recording Academy's producer and engineers wing, or just P&E wing. Also known as NARA's National Academy of Recording Artists and Science, the P&E has renowned producers and engineers, and it is responsible for the Grammy Awards. In 2004, they issue a recommendation concerning the use of multi-channel system for 5.1 format. This document presents some recommendations that are relevant to acoustic control room projects, and I'm going to compare them with our measurements in this control room. First thing is background noise. We know all the equipment should be power on and should not exceed 25 SPL A weighted. No two rooms dimensions should be equal. The ceiling height ideally should be greater than 11 feet or 3.35 meters.